Sushreeya, and today I have my front whiteboard with me to help you understand even more today, okay? I'm having a great day so far, and I think I'll have a better one today with adding my scientific speech. So, today for you friends, I've chose a very exciting topic. Do you want to know what it is? Of course. It is atoms. Well now, do you know what atoms is? Easy definition. Well, it is the basic building block of all matter. It's said by scientists that they think, atoms are probably one of the smallest things. But they even found other smaller things that you'll learn later, like gluon and quarks. But we'll talk about that later or some other time, okay? I'm not trying to confuse things. Okay, so let me show you a basic picture, okay? So if you see here, so when you do, and this is a proton. The red is a proton. When a proton is positively charged. Now, if you see here are a couple of protons, and there are spaces for another type of friend they have here. Now you will also get to know. Now you see another one. This is a neutron. What is a neutron? A neutron is a perfect score of atoms. So the proton is just a little more than the neutrons. So now I'm just going to do it a little bigger side. Okay. Those are, so let me just make my protons a little bigger for you guys. And now we will show the nucleus. A circle. This is the nucleus. This nucleus protects the inner heavy part. Now you will also learn about another thing. Now as you see, electrons. What are electrons? Well, if you can see, electrons don't go on the nucleus. I have to make another outer line to have the negatively charged electrons. Protons, neutrons. Proton, like I said, is a little heavier than the neutrons. But if you think of this small little electron, both of these, this and this, both are the way bigger size or mass of electrons. Put them together, 10 times larger. It is so huge and way heavier than the electron. So if you make, let's see friends, here I will make a line and another line. 2 lines for the electrons. Electrons is a negatively charged and positively friends with electric magnets. When an electric magnet passes by, it goes to the edge or comes towards. That's how the electrons get its power. If you can see, you can put them anywhere. But electrons should never touch each other. Now, speaking of atoms touching each other, nucleus, I'm going to scooch this a little up here. And now I want to show you a famous scientist's experiments. His name's Ernest Rutherford. If you saw in another speech, I talked about Marie Curie. Ernest Rutherford is a student of Marie Curie, and his son, William Chadwick, also had another thing. He discovered all this and experimented something with his teacher, Ernest Rutherford. So both of them, Chadwick and Rutherford, both loved experimenting, but there was a problem with Rutherford. He noticed something going wrong with his atoms. Here, let's say this big red, I'm not going to color it in, waste your time. That's a nucleus, okay? Now, I'm just going to kneel down here. Now you see all these little things, right? And a small one here. Now, I'm going to point the direction. This is the way this is going. It's going just fine so far. This is going so far. Wait, but look. I hit something. And it goes the opposite direction. Now look what happens here. Same to me. Oh no. And it goes that way. And this is a perfect fine square. But no one yet knows until Rutherford's experiments why this is happening. Scientists have to experiment this properly in order to understand the way this atom and the nucleus works. For some reason, it's the opposite thing with electrons. If you do all this, so for example, if you turn this to protons, they experiment the same thing. Now, if you do all this to green, or do it as an electron, they find it really different. If it goes through, why does it just go through the nucleus? It doesn't make sense for scientists, and the world is not easy with the study of atoms. Because of this, we have to try to be more smart, intelligent, and try to figure out all the secrets of atoms by the time our world ends. Now, there's Thomson. He just kind of studied atoms a little. He was a physicist. So he noticed that, here, I'll show you. It's kind of hard to explain, but the thing is that, let me note that. So remember, here I have the neutron. Here I'll have the electron. And then what's left? The proton, right? So now, as if you can see all of this, you can see all of them, these two only match, but it goes through in a different cycle, I used to know. But if you put these in the cycle together, so it would go on the top, the protons, then at the bottom, and then they all act like friends in the same family type as you see in this picture, right? So, what makes it go together? Like I said, I'm just going to tell you a little. He noticed that there are gluons, smaller than atoms. But atoms still make up the smaller items of itself anyway, as a quotation mark for yourself. But, here, I'll show you. And then there were some gluons that keep it together when they hit as a bond together. And that's sometimes what scientists think forms the nucleus, that a bond of all togethers of protons, electrons, and neutrons, but they haven't finalized it. But all it goes together, kept with the gluons. Now, do you know what is the periodic table? The periodic table is where all elements are. All elements have their own atomic number. The atomic number tells how much atoms each element have. Well, now, as you can see, hydrogen, let's take an example. I'll tell you a couple. Hydrogen, if you see, has 1. Then if you go to maybe helium, it has 2. Oxygen has 8. This is all I wanted to talk with you about our amazing story of atoms, and still has many secrets unknown, okay? So this is what I wanted to talk to you. Are you very curious about the unknown secrets? I am too. But who knows who will work to find them out, such as Rutherford and his students. Okay? Have a good day. See you soon.